All right, guys, we're looking at 7.4, solve and write multiplication equations, and that starts on page 551, which looks like this. All right, we're going to skip over the vocabulary startup and go straight to the real-world link. It says that Matthew is downloading ringtones. The cost to download each ringtone is $2. When Matthew is finished, he has spent a total of $10. Let X represent the number of ringtones. What does the expression 2X represent? So they're telling us that we're going to let X represent the number of ringtones and that its cost is $2 a download. And Matthew is finished. He's spending a total of $10. So what do you think 2X represents? What parts does that represent? So I think when you look at it, when we've got X, we're talking about the ringtones. And when it talks about 2, it's talking about $2 for each download. So hopefully you look at that 2X, and you know that the 2 is representing the money, the cost for each download. Okay, for each download. And that the X is representing the number of ringtones. So how many ringtones that they buy. So 2 times X means it's $2 for every ringtone and the X number of ringtones. So if it was, for instance, 2 ringtones, it would be $2 times 2 ringtones, which would be $4. If it was 10 ringtones, it would be 2 times 10, which would be $20 for the ringtones. So that's what our 2X represents. So it says solve a multiplication equation. A multiplication equation is an equation just like 2x equals 10 because the variable x is multiplied by 2. Multiplication and division are inverse operations. So to solve a multiplication equation, we use division. Remember, to solve equations, we need to use the inverse operation. The inverse means opposite. So if you haven't written that down in a while, let's write down inverse equals opposite. Okay? So if we're talking about multiplication, the inverse is division. When we were talking about addition, the inverse was subtraction. When we had subtraction, the inverse was addition. When we have division, it'll be multiplication. So we're doing the opposite. So to solve a multiplication equation, we're going to use division because it's our inverse. All right, so example number 1 is using that example, 2x equals 10. Ultimately, we want to know what x is, and remember from the story that x represents the number of downloads. So they're $2 each, x the number of downloads, we paid $10. How many downloads did we get? So 2x plus 10. So I'm going to do my math over here, and I'd like for you to do this as well. We're going to do our OSS. Original, substitute, solve. Our OSS. If you haven't heard that yet from Miss Rickfelder, you're hearing it now. OSS. Original is the 2x equals 10. You have to write it. The substitute and solve, we need to find what x equals so that we can substitute it in. All right, so we're going to do our T-chart. I know you love my T-charts. Draw it. Now, what's the opposite of 2 times x? Hopefully you remember from 2 seconds ago that the opposite of multiply is divide. Check out how, and they do it over here as well, this is how I like to write my divide. By using that fraction bar and doing divide by 2. Not using this, because I really want you to see why using this inverse operation works. So here's what happens, and I'm not going to explain this every single time, but it's important for you to see why it works. We're going to do divided by 2, okay? What we do to one side of the equal sign, we do to the other. That's why we put our line through our equal sign. Now our 2's, look what happens. What's 2 over 2? 2 over 2 equals 1. What does 1 times x equal? I hope that you're saying x. So here, this is what we're going to do. Instead of having it say 1 times x, we're just going to cross those out like we did before with our subtraction or addition. We're just going to cross it out, and we're left with x over here. because we know that it's going to be 1x, which is just x. And then we're going to do 10 divided by 2, which is 5. And so our solution is x equals 5. When we substitute that in to check our work, because we are always going to check our solution, we set up the OSS again. Original, then we're going to substitute, and then we're going to solve. And sure enough, 10 equals 10, there's our check mark, because 2 times 5 equals 10. So in the answer to the original one, how many downloads could we get for $10? It's going to be 5 downloads for $10, because they're $2 each. All right, so now we're not going to fill in this little area here, because I'd like, well, actually, we don't need to block out the check part. We're just going to check out this area, because I want to do our t-charts, okay? But I do like that they're talking about our coefficients. Let's review. Remember that coefficient, we talked about this when we were talking about terms. When we have something like 3x, 3 is our coefficient. Then what is our x? X is our variable. So when we have 3x, the 3 is the coefficient and x is the variable. So remember that. Now let's set up our t-chart. Let's see if I can make some space for us. Just, you have your side of the paper. I'm going to try and make some space here. We're going to start by doing our OSS, setting up our equation. The original equation, which is, let me pick a color now, 3x equals 6. And we're going to do our beautiful t-chart. So through the equal sign, give us some space, and underline the equation. So now we've got 3 times x. We want to do the inverse operation, the opposite of times. We're going to do divide. Remember I said to write it like it was a fraction, because I think it's really easy to see that you just go like this. And what we do to one side of the equation, we do the other. That's why we put our line through our equal sign, so that we remember to go to the other side of that line to do our divide by 3 again. So now on this side we're left with just x, and on the other side we've got 6 divided by 3, which is 2. And so I think that you guys know that 3 times 2 equals 6. I don't doubt that for a second, but remember that we're using this because it's going to get harder in the future, and we're using this process with the t-chart every single time. Now to check our work, because we always check our solution, we're good little kids like that, we're going to do 3x equals 6. We say that x is 2. 3 times 2 is 6. 6 equals 6, check mark. But our real answer is x equals 2, and that's why you should be circling it. Otherwise, you're going to tell me that the answer is 6, and no, it's not, it's 2. All right, my darlings. Now you're going to do A, B, and C on your own. Go ahead and pause the video. I'm telling you, pause the video. Don't mess around and just copy my answers. Pause the video and do it on your own. Thank you very much. All right, guys, so looking at A, B, and C, here are my answers. Again, of course, I know that you know that 3 times 5 equals 15, but you're doing the t-chart anyway. Thank you so much. If I don't see the t-chart on your work, I'm not giving you credit. All right, guys, so make sure that you circle your answers when you get them, and then I also want you to check your work. So if I don't see those 2 things, then you're not doing it right. I need you to solve for x, and then check your work. All right, so x for A is x equals 5, for B it's 2, and for C it's 7. I want yours to look just like mine. I'm modeling for you exactly what I want to see. When we check our work, we start with the original, we substitute, we solve, and hopefully we get a check mark. All right, so check those, continue checking those if you need to. You can always pause your video if I don't give you enough time to check your work. All right, so for the division property of equality, we've got if you divide each side of an equation by the same non-zero number, the 2 sides remain equal. So they're just showing you, just to make sure that you believe them, that if we have 18 equals 18, I think that we can all agree that 18 equals 18. Whew. So now I'm going to have you check this. You know, I'm wondering if I was putting my hand over that mic the whole time. I hope that you guys could hear me that whole time. Can't believe I was doing that. All right. So what we need to do is divide both sides by 6. When we do that, we see that we still are equal with 3 equals 3. It's same for algebra. As long as you do it to one side, you do the other, we're still equal. We're still in balance. So when you solve an equation by dividing both sides of the equation by the same number, you are using the division property of equality. So if division is the way that we have to solve it, then that's division property of equality. All right, example number 3 says Vincent and some friends shared the cost of a package of blank CDs. The package cost $24 and each person contributed $6. How many people shared the cost of the CDs? So in words, we want to find which amount each contributed times the number of people, and that equals the cost. Okay, that seemed a little confusing, but I like to do this in terms here. So we've got the amount of money that they each did times the number of people, right, equals the cost. So the money that each person contributed was $6. The thing that we don't know is how many people contributed. So we're going to call that a variable, X. And then the total cost was $24 because we've got that right here. All right. So we have 6x equals 24. When we're solving to figure out how many people contributed, we're going to do our T-chart. And we're going to say, okay, we're going to divide by 6 here, divide by 6 here. We get x by itself. And then 24 divided by 6 is 4. So the number of people are 4 people who split the cost of the CDs. And what they're saying is with the bar diagram, you can set up this bar diagram, and this all represents the $24. And then each person puts in $6. And we got to figure out how many of these blocks would we need to be able to have a total of $24 when we only need 4 altogether. And so we find that 4 people contributed $6. If we had 5 people, we'd have $30. That's not what we're looking for. So that's how we use that little bar diagram. All right, so you're going to do example D, and when you come back, I'll have the answer. We'll go over it together. For D, it says, in 2004, Penn Haddo and Simon Murray walked 680 miles to the South Pole. The trip took 58 days. Suppose they traveled the same distance each day. Write and solve a multiplication equation to find about how many miles they traveled each day. And the reason we're saying about, I don't know why we're saying about. Maybe, I wonder if we have to round it. Okay, well, we'll find out. This part is making me question it, but let's see. So the total is 680 miles. Okay, and the trip took 58 days. So I'm taking this number, and I know that ultimately I've got 58 days. I want to know how many miles I went in that 58 days. So if I were crazy and I was actually going to put a billion of these things, I need to put 58 of these lines, and this is the amount that I don't know. This is what I don't know. How many miles did they go in those 58 days? So we need to write and solve a multiplication equation. A multiplication equation. Yes, I know that we can do 680 divided by 58, and that tells us how far they went in one day. But do you see this right here? This is a division sign. And they said we want a multiplication problem. So we're not doing the right thing. So if we know that this is going to equal this, if I work backwards and I say, okay, y times 58, isn't that going to equal 680? Isn't that how we check a division problem when we get the answer, is that we can multiply backwards? So let's set this all up again. Let me start over. We're going to say, okay, we've got 58 days times x equals 680 miles. So 58 days times x miles equals 680 miles altogether. So this is the right multiplication equation. Now we need to solve it. So to solve it, you should have done your t-chart. Your inverse operation to multiplication is division. And sure enough, we're going to do 680 divided by 58. And we get x equals 11.7, let's say. Because I'm not going to go through and keep going with my decimals. This is why it said about. It's because we're going to have to round it to 11.7 miles. Instead of having to figure out exactly, I think this is going to go on for quite some time. And I don't want to keep dragging on my decimals for a long time when really all we're going to talk about is they went about 11.7 miles. Okay? So that's what that about was all about. I thought that might be the case. All right, so let's stop and reflect. Going back to example 3, it's asking us what is the coefficient in the equation. And I just got done talking to you about coefficients, so I'm hoping that you can look back at example 3 and figure this out. So pause the video now, and let's go back. All right, guys, back to this first example. Our equation was 6x equals 24. The coefficient is the number in front of the variable, and that is 6. So if you answered 6, you are correct. All right, so 6 was our magic answer. All right, example number 4 says solve 3.28 times x equals 19.68. Check your solution. Of course, we're going to do our t-chart, and I'm going to pretend like that's what they're doing. So here's our t-chart. We divide both sides by 3.28, and 19.68 divided by 3.28 is 6. To check our work, which we always should do, we go. Look, here's our original, our substitute, and our solve, our OSS. We've got 3.28 times x equals 19.68. We substitute in for the x, the 6, and we multiply 6 times 3.28, and we get 19.68. Great. All right, now, because this is why we don't try and do mental math. I don't think that you guys probably know most of these mental math. The t-chart is going to come in handy. So please go ahead and do your t-charts and check your work. Pause the video now. I want you doing this on your own. Don't just copy me. Don't be a cheater. All right, guys, here are my answers for E, F, and G. Notice that I checked my work. I put in my original, and then I substituted. But of course, when I'm multiplying with decimals, I'm not going to multiply 2.25 times 3 this direction. I'm going to do it this direction. So that's why you see my work look like it does, because I'm checking it for real. I'm not just putting the numbers there and putting a check mark, because that's not going to help you. All right, so E, F, and G. Now, I need you to get out a separate piece of paper for this, because the book doesn't go over fractions, and we really need to, because they're not going to go away, and there's going to be examples on your test as well as upcoming chapters. So we have to understand how to do this. So please get out a separate piece of paper. Pause the video now while you do so. All right, let's title this Extra Notes 7.4, okay? And we're going to have 2 examples that I'm going to work through with you, and then I'm going to give you 2 got it questions. So go ahead and copy this example 5 down. If you want to switch up colors like I did, it might be easier for you to look at it later, so I would highly recommend that you do that. So every time I change a color, maybe you should. That would really be helpful. All right, so 3/4 times P equals 12. We're going to do our t-chart. Through the equal sign, give yourself some space to work. In this case, I'm giving myself a bigger gap, and I'll talk to you about that in a second. I'm giving myself 2 lines. So we have 3/4 times P equals 12. So if I've got 3/4 times P, just like if it was 3 times p, what do I need to do? Division. I need to do the inverse operation. So the opposite of multiplication is going to be my division. So I'm going to divide by 3/4. So I'm going to divide this side by 3/4 as well. So that makes this go away, and I'm left with p equals. Here's the thing. Let's rewrite this off to the side. This is 12 divided by 3/4. Think back. Can we do this the way that it is right now? Can I do 12 divided by 3/4? The answer is no. I cannot do it the way that it is right now. So what I need to do, if we remember, dig back in your brains to KCF. We're going to keep 12 over 1. We're going to change division to multiplication. And we're going to flip 3/4 to make it 4/3. Remember what this is called? Reciprocal. I know it's been a while. Okay, that came out really sloppy. I know it's been a while, but that's what that was, the reciprocal. All right. We cannot divide with a fraction. If you have a fraction, you cannot divide. You have to do KCF. There's no option. So keep, change, flip in that order. Keep, change, flip in that order. So we've got cross-simplifying that we can do now. And remember, anytime that we can cross-simplify, we want to because it's going to make an easier problem for us. So 12 and 3 can both be divided by 3. So 12 becomes 4 and 3 becomes 1. If I rewrite this, I now have 4 over 1 times 4 over 1. And we do hamburger, which is 16 over 1, which is just 16. And I know it doesn't seem like the answer to 12 divided by 3/4 is 16, but it's 12 being divided into small pieces, smaller than 1. If they were being divided into 1 piece, there'd be 12 pieces. Well, this is being divided into even smaller pieces, and so there's 16 of these pieces. So to check our work, because we always check our work, and this is really, really good idea for these, we're going to go back to the original. We're going to substitute 3/4 times 16. We're going to make that 16 over 1. If we cross simplify here, we get 1 and 4. And then we do our hamburger, because it's now 3 over 1 times 4 over 1. Hamburger is going to be 12 over 1, which is 12, which is what we had in the beginning. So that is correct. So the answer is P equals 16. I'm going to show you the next example. Actually, I'm going to start over this example, and I'm going to tell it to you in a different way. So please write this example again. 3/4 times P equals 12. All right, guys, so I want to give this to you in another way, because if you can learn this other way, it'll be so much faster than having to write out 12 divided by 3/4 and doing KCF. Here's the thing. We know that we're going to have to do KCF, which means keep the first, change the second, and then flip the last. What that really means is, look at this. It means multiply times the reciprocal. Remember I told you the reciprocal is when you just flip it? If you can remember that you're multiplying by the reciprocal, let me show you how this makes sense. Look. All right, let me change the color so it doesn't get too confusing. It's a lot of stuff going on. All right, I'm going to multiply times the reciprocal. I'm multiplying my 3/4 times the reciprocal. Do you see what I've done here? The reciprocal is just the flip. And what I do to one side, I have to do to the other. Let me just show you something here. On the left side, my 3's, don't they cross simplify out to make 1? And then don't my 4's cross simplify out to make 1? And so ultimately I have 1 over 1 times P, which isn't that just 1 times P, which isn't that just P? And so if I multiply times the reciprocal, crisscross, I'm done. I now have just P. And whatever I do to one side, I do the other. So I'm going to multiply this side by the reciprocal, which was 4/3. If you can remember that, multiply by the reciprocal, crisscross here, crisscross applesauce, crisscross, it's gone. The X marks the spot, it's done. So we get P equals, and then we can work on 12 over 1 times 4 over 3, cross simplify. Here's my 4 and my 1, and then I get 16 over 1, which is just 16. Answer. I don't know if this is going to be something that'll latch on for you guys, but it would be great if it could. I'm sorry this video is already getting so long. These extra notes are very important. So the next example is 6/7 times y equals 3 3/7. So of course, you're going to get some mixed numbers sometimes. You're going to have two sets of fractions. Life is life. Okay, it's not always great. So here's what we're going to do. T-chart. Remember what I just said about multiplying by the reciprocal? If I do times 7, 6, because I'm flipping, the reciprocal is flipping. Look at my 6 cancel out, my 7s cancel out. Wasn't that nice? Now don't forget, what I do to one side, I do the other. So if I'm multiplying times 7, 6 on this side, I have to do the same thing on the other side. So again, I'm going to crisscross out, my 7s cross out, my 6s cross out. I'm left with y equals, and now I've got 3 3/7 times 7 6. Okay, I can't multiply it the way it is right now. I need to do mad. Okay, I need to make this into an improper fraction. So I need to make this, I'm going to do multiply and then add, mad. So I've got 7 times 3 is 21, plus 3 is 24 over the denominator. Now we can multiply that times 7 6. We can do some cross simplifying, some fancy footwork. These 7s can cancel each other out. The 6 and the 24 can be divided by 6, and so I get 4 over 1. And so if I were to rewrite this, this is 4 over 1 times 1 over 1, which is obviously 4. So y equals 4 is my answer. We're not done. We're going to check our work. So we're going to do 6/7 times y, 6/7 times 4 equals, all right, so we got to put 4 over 1. We're going to do hamburger. There's no cross simplifying. It's going to be 24 over 7. Well, we make that into a mixed number, and it's going to be 3 with a remainder of 3 over 7, which is check. So the answer 4 does work. I know that one was a little crazy, but there you go. It was a lot of work, but we're going to multiply times the reciprocal so we can do the x out. What we do to one side, we do the other. And then to be able to multiply a mixed number in a fraction, we've already learned that we have to make it into an improper fraction. And then we multiply those, and we got 4 as our final answer. Don't forget, cross-simplifying makes things so much easier. So much easier than doing 24 times 7 divided by 7 times 6. What a pain. All right, guys, now it's on your own, H and I. When you come back, I'll have the answer shown in all my beautiful work. Pause the video now. Do it on your own. Very important. All right, guys, so for H, you should have gotten 60, and for I, you should have gotten 8. So I hope that you guys got those answers. If not, look over how I did my work. I know it's a little crazy, but I don't want this video going over 30 minutes. It's already long enough. All right, guys, I will talk about these more in class. We'll do more examples. I hope you have a great day. See you in school.